I'll just put a high level architecture of this project. So what we have is, so we have a data being ingested. So we have our HDFS here. Yes, Samir, it is being recorded. So we have our HDFS here. Data is ingested. A simple script we are using, shell script. Shell script to ingest the data. And we know that the data are two types of data. One is clicks data, which we call it as omnichar. And one more is sales data. So we want to figure out what all sales did happen in corresponding clicks. A user might be browsing the website. While browsing the website, the user has purchased something. So we have the purchase data and we have the clicks data. So we want to figure out what all purchases did happen in a particular sessions. We are actually doing a sessionization on the clicks data, and in a particular session, what all sales did happen. So what we are doing is we are creating tables in the Hive. So this table we call it, we create database in Hive. One is raw database. One more database that we are creating is processed database. One more database that we are creating is warehouse database. Now when we are ingesting the data, we are ingesting omnichar data, which is nothing but our clicks data and our sales data. So for omnichar data, we have a omnichar table. This is a omnichar table, and similarly we have created sales table. So everybody know, the people who are aware of the project, we know that we read this omnichar data through the, first what we do is, after ingesting the data, we are creating partitions. We are creating Hive partitions. This is our job one. So we will be ingesting this ingestion will happen every hour. Somebody is on unmute. There is a slight disturbance. I think Santosh. Santosh, you have any questions? I am putting you on mute. So every hour we are ingesting. So we are creating a partition for every hour. That was our job one. The second job, what it does is, the second job is our Spark job. Spark job 1, where we sessionize and we adjust the timestamp. And after doing that, we save it to processed DB, and again we create a omnichar table. So if you remember these things. Next we run the next job. Spark job 2, which reads the sales data, which also reads the processed omnichar data, and we adjust timestamp, and we also adjust user ID if you remember. And save it to the processed DB as a sales table. Next what we do is we run one more Spark job 3, which reads this both processed omnichar data and processed sales data. Does sales to session mapping. It does the sales to session mapping. I mean, in a particular sessionization was done by the Spark job 1. Now in the Spark job 3, we are doing what all sales did happen in a particular sessions. Those things we are storing into map sessions table. So that's what we are doing. So this is a ETL job. Now since we are running it every hour, I mean to say, since we'll be ingesting this data every hour all these jobs has to run. So as soon as we ingest at 7 o'clock, Hive should partition the 7 o'clock's data. Once that 7 o'clock's data is partitioned, Spark job 1 has to run. So it has to be in this form we discussed that. As soon as the ingestion of data is over, Hive partition is created. A subdirectory will be created for representing 7 o'clock's data. After that, Spark job 1 will run, which will only read that 7 o'clock's data and save it into process DB. Similarly, next Spark job 2 will run. Then Spark job 3 will run. And the same thing has to get repeated every hour of the day, because every hour the data will be ingested. So at 8 o'clock again we'll ingest the data. At 9 o'clock again we will ingest the data. At 10 o'clock again we'll be ingesting the data. So this the Hive partition should create a subdirectory for 8 o'clock's data. Now here Hive partition, again this job should create a subdirectory for 9 o'clock's data. And so on, all the Hive should work in that fashion. Similarly, Spark job 1 which runs at 8 o'clock should only pick the 8 o'clock's data. Similarly, Spark Job 1, which runs at 9 o'clock, should only pick the 9 o'clock's data. So these things has to run every hour of the day. So to run all these things on every hour of the day, so we need some automation framework or job scheduler. So that's what where we have is Oozie comes into picture. So we will be scheduling these jobs one after other. So you don't you should not go and manually say Spark submit every hour of the day. So it should happen automatically, so that automation or orchestration is achieved through multiple frameworks. One among that framework is the Oozie framework. I mean to say you can use Oozie for automation or Azkaban. Sorry. You can use Azkaban, you can use Airflow and Pinball something is there. I think it's Pinball. So multiple frameworks are there. This is from Yahoo and now it is under Hadoop. Azkaban is from LinkedIn. Airflow is from Airbnb and Pinball is from Pinterest. So you can use whichever automation framework you want. It could be used. For this project, I have used Oozie. I have developed one more project which is credit card fraud detection, where multiple frameworks are involved. So I tried Airflow, and Airflow is also good. I mean, much more simpler than Oozie. I mean, I did not go to the more depth of the difference between Oozie and Airflow. Airflow is quite a bit easy to learn. I mean to say, it is written in Python, and you can write Python code here as scripts to run your jobs. Oozie is XML based. It gets slightly tricky to understand Oozie as compared to Airflow. I haven't learned about Azkaban or Pinball. I think they should also be on the similar grounds. So let's understand this Oozie part a bit. Now Oozie, as I said, is a automation framework or workflow scheduler, whatever workflow job scheduler we can say. So you can run a single job, you can run multiple jobs, you can run, I mean, lot of things are there. There are three things in Oozie, three types of workflows. First one is a simple workflow. Second one is coordination workflow. Third one is bundle workflow. Now, what is a simple workflow? Simple workflow is nothing but you just want to submit a single job. Simple workflow, just run, just you want to run single job. That's all. So that's the only thing we want to do. In a similar fashion, what is coordination workflow? So if you see here, so you want to run multiple jobs. You want to run multiple jobs on a timely basis. So this is actually a coordination. So you need to have a coordination Oozie workflow for this. Sorry, simple workflow is nothing but it's not just, yeah, it is just running a single job, right? Coordination workflow is nothing but these kinds of jobs can be run through coordination workflow, one after the other. First high partition job will run, then Spark job will run. Only after the completion of high partition job, Spark job 1 will run. Only after the completion of Spark job 1, Spark job 2 will run. Only after the completion of Spark job 2, Spark job 3 will run. So that's what we mean by coordination. So coordination based on the previous job, also coordination based on the timestamp. So we want to run this set of job at 7 o'clock. We want to run this set of job at 8 o'clock. We want to run set of job at 9 o'clock. So these such things come under coordination work. In a similar, so here you will be running multiple jobs based on time and data dependency. Now what is bundle job? Bundle job is running multiple coordination jobs. Workflow. Sorry. So running multiple coordinate. You will have one set of coordination. This is one coordination flow. This whole thing is coordination workflow. This whole thing. This whole thing is one coordination workflow. Such type you can have multiple use cases. This is one use case. You can have multiple use cases, multiple projects. All those things you want to club together, and independently they will be parallelly running as separate coordination jobs. Or sometimes it could be one coordination job may be dependent on the one more coordination job. So such clubbing together of all such coordination jobs is nothing but called as running uh, bundle jobs. So that's the overall view on what is simple workflow, coordination workflow, and bundle jobs. So you will get more details on. You can search for Airawat. So there is a GitHub link, and also a blog should be available. So where there are a lot of Oozie examples, she has explained it in a very good fashion on all the Oozie jobs. I too learned from this blog itself, and very well explained. Oozie, yeah, as you can see here, this blog is very much of a, this is really very good. I'll just ping it here on the chat window. I'm just pinging it, and you can check that. And just before that, there is a very first document. I mean a blog which says how a Oozie looks like. So there will be a Oozie client. There will be a Oozie client, and there will be Oozie server. So whenever you submit a job, you submit from some Oozie client. Oozie client in case of uh, uh, Hadoop as of now is some client, some console client. Or if you go to Cloudera here, so you can think of Hue is a Hue is a web-based interface for your Hadoop architecture. You can think of Hue as your Oozie client. So this is your Hue web interface. So there you can give queries as well. You can workflow using the workflows. You can have simple workflows. You can have coordination workflows. You can have bundled workflows. So these you can think of as a Oozie client. From here you can submit a job also. So this submitted jobs will go to the Oozie server. Oozie server, and Oozie server will schedule these jobs. Oozie server will schedule these jobs on the Hadoop cluster. When I say Hadoop cluster, it is nothing but Yarn cluster. Yarn will be acting as your operating system, and HDFS will be your file system. Now, now we discussed about a simple workflow. A workflow will always have two files. You have to edit two files. Simple workflow. I'll give an example for simple workflow. Every workflow will have two files. One is properties file. One is properties file. One more is XML file. Every workflow, not just for simple workflow, these are the minimum two files that will be there. In properties file, you define configuration parameters. Config input parameters. XML file, you define your job. What job you want to run. how the job wants to run. So those things you define in your XML file using XML. Properties files, the input parameters or the configurations parameters that you define in your properties file will be taken as input to your job file. So properties file will be your input to your XML file. So let's see a simple example. Let's see a simple example on how this simple workflow looks like. So I will take this itself. We know that these jobs are coordination jobs. Before we start running our coordination job, I mean to say, before we start these things, we need to set up Hive. First, we need to set up Hive. So first step will be will set up Hive tables. Hive set up Hive databases and tables. That will use a simple workflow. I'll put it. The very first thing that we'll do is we'll set up Hive database and table using simple workflow. So let's see how it looks like. Right. Yes, Chandrakant. Hive setup DB and tables is a one-time job. So that's the reason we are using a simple workflow. Because simple workflow, as I said, is used to just run a single job. As we can see, simple workflow is just to run a single job. So and we know that, and I said that simple workflow has two files. One is properties file and one more is XML file. So actually I am in my AWS account. So what I have done is I am running a 4 node cluster. I have a name node service running and your Yarn resource managers, all those things are running here. And we have a data node service running in these 3 nodes. And also the uh, uh, node managers are running in this. And separately, I have configured a system for Cloudera Manager. Usually, uh, a lesser instance should be fine. All these are paid instance. So you cannot have a free instance for M4 X large. All these are paid instance. You will be charged for this. I mean to say, if at all you set up a cluster, you will be charged. It's uh, I will not be charging anything for my setup. So as we know that I have one name node, one and three data node services and one Cloudera manager. And the Cloudera manager is running on, as you can see, Cloudera Manager is running on this IP address. This is your publicly accessible IP address. So if you want to access, you have to use 7180 port. I think most of the people know this. So these are all our hosts. We have HDFS, Hive, Q, Oozie, Spark. Everything is up and running. I think somewhere something is, the monitors are failed. Anyway, that should be fine. So from there we are using our Hue. So if you want to use Hue to schedule, I mean, using the web UI, I can schedule the job, or I can schedule the job through the command prompt also. So what I have done is, my name node is this. So if you see, my name node is running on this IP address. So I have to just connect to this IP address to log in. So you can always say connect button here. So you can check the connect button here. So it will showcase how you can connect. So it shows the root here. Actually, that's wrong. It is Ubuntu. I have created an Ubuntu image. So I need to use, this is how I need to SSH to my Linux system. This is my name node. So I have kept my keys here in the documents folder. In the documents, I have my keys inside the keys directory. Inside the keys directory, I have my cloud. I will SSH to my name node service running on AWS. So I am in my I'm in my name node service now. So here I have created one more user. I have created one more user. So I will switch to that user. su hyphen, that username that I have, new user that I have created here is HD user. This is how I switch to that HD user. My HD user password is Hadoop12. I was doing some experiment to download things from the Google Drive. So there are some GitHub repositories available. You can install those things so that you can upload and download something from a Google Drive. So that experiment is not yet finished. Anyway, I have my code drops here. If you remember e-commerce marketing, we created code drops and data drops. If you remember that, everything I had put it in the code drops, and whatever data, the demo data, I had kept it in the data drops. The same thing you have to do, and upload everything to your Google Drive. This is, sorry, upload everything to your EC2 instance. From your Linux machine, upload everything to the Linux, your EC2 instance. So you can do that. Downloads. This is my local system. Downloads, training, Spark. e-commerce marketing pipeline. So there is something called as deploy to AWS shell script. So I have a deploy to AWS shell script where you have to specify your. I am uploading everything to the name node name system where the name node is installed. So you need to give the IP address of that name node. This is where I want to copy all the files. Just do a maven clean package. This will build all your files and it will create this directory in your local file system. Local file system. And we know that from one system to another system, if you want to copy, we just use SCP command. SCP is to copy from one Linux system to another Linux system. Since we want to copy to my EC, since we want to upload all the data, I mean demo data and code to the EC2 instance, so I need to use my EC2, I mean PEM file, copy the contents of the build files to my Ubuntu system and the destination IP and the code drops. I just copy, I mean you don't need to run this script, you can copy one by one and run the each command individually also. The idea is to copy all the data. If you remember, I will just show what all the contents is here. If you go to the code drops, if you remember, we had demo data, HDFS, local. Here, local contains just before that. I said that in simple workflow, you need two files. One is properties file and one more is XML file. This XML file you have to save it in HDFS. You have to put it in the HDFS. Properties file will be in your local system, local file system. This you need to keep in mind. Properties file will always be there in the local file system. Your job definition XML file should be there in the HDFS. So what I have done is, so whatever files will go to HDFS, I have kept it in this folder. Whatever will remain in the local EC2 file system itself, I have kept it in this local folder. So this whole thing I will copy to HDFS. This whole thing I will copy to HDFS. So if you see here, if I go to HDFS, so there are multiple things we want to copy. So I have structured it as what all Hive things I have to keep it in HDFS. What all Oozie things I have to keep it in HDFS. What all Spark things I need to keep it in. The Spark is nothing but our jar file. So if I go to the Spark, so this is our created jar file. You should not create a Uber jar. This is not a Uber jar. It is, this jar does not have any dependency because all the dependencies are already there in your cluster. Only which is not there in the cluster, you have to create jar out of that. You have to create a jar out of that, and our form.xml handles that. The shaded Maven plugin. So this this plugin will handle to create a jar only which is required, only which is shaded is here. So this will not create a Uber jar. It will create only the jar which is required. We can check that how our jar file looks like. It does not include all the dependency. Otherwise, you will get an mismatch in the version of your dependency jars and the jars that are available in the yarn cluster. So it does not have all the dependency jars. So you can also check the size of this. It is just 18 MB. Usually your Uber jar or a single jar will be around 180 MB or 120 MB, somewhere around that. This does not contain all the things. It only has the required jar files. So that all those things which will go to HDFS, I am storing it in HDFS. So if you go to the Oozie, as you can see, there are XML files. Yeah, here is a question. The question is, what is Uber jar? So Uber jar is nothing but a jar with all your dependency. Your Spark job depends on Hadoop libraries. The Hadoop libraries internally depends on some comms libraries, some CSV libraries. Lot of libraries will be there. So everything will be bundled in one jar. So such jar we called as Uber jar. But we don't need a Uber jar here because most of the libraries are already available in Hadoop cluster. So we just create a jar what is required for us. So as I said, all these things, this is our simple job definition XML file. So since it will go to HDFS file system, I have kept it in a folder called HDFS. So that's how I have organized it. In our code drops, I have local, I have HDFS, and our demo data also I have kept it here itself. This ignore this. This is to run in your system only, in the laptop. That also got copied here. So only thing is you need to copy this folder from your system to the EC2 instance using the SCP command and giving your credentials or the PEM file. Very first thing is nothing but set up HDFS. I mean to say, copy the contents of this directory to your HDFS file system. So if you go to this script, so since we want to copy the data to the HDFS file system, we need to know the name node. Our name node is running on this IP address, and the port number is 8080. If you remember, I always used to say localhost on my laptop. But since we are running it on a multi-node AWS cluster, so the domain name, sorry, the IP address of the name node service is this. So you can get the IP address. I'm using the local IP address. I mean to say private IP address, not the public IP address. This is the public IP address, public DNS. This is the private DNS. 10.0.109.11. 10.0.109.114 is your IP address. How do we know that 80820 is your port number? So everything will be available in the etc folder. You can go to Hadoop conf, so you can check for, I think, core site or HDFS site.xml. So it says that this is your name node service. So that's what I have taken. That's what I have taken. And this is this shell script that I will be running is just to copy the things to the HDFS file system. Whatever should be copied to the HDFS file system, like the Spark jar file, like Oozie's XML file, some Hive scripts, all those needs to be there in the HDFS file system. Hence, this is a simple script what I am using to copy the things. So this is our name node. So I have created a home directory. Inside the name node, user HD user. So I go to HDFS. We have name node link here. Utilities. So I have created this HD user. When you install Cloudera, you will not have this folder. So you have to create this HD user. So the way I created this is Hue gives you a very good way of adding users. So if you go to the Cloudera manager and go to Hue and you go to the web UI links of Hue, and on the Hue, if you go to this icon, HDFS browser, so from here also you can browse the HDFS. Through the name node service web UI also you can browse the users. But this is more flexible. Hue's browsing is more flexible. You can delete a file, you can edit a file, you can do lot of things with the Hue's file browser. So if you want to create a user, so you can go to manage users. Manage users, I created a new user by clicking on add user. So you can click a new user, like your username, give the password, and it will add a new user, and also it will create a home directory. In the same fashion, HD user was created. So that is my home directory. So you can create any of your users and you can make it as your home directory. So my home directory is the name node service, user, HD user. Inside that I'm creating a project directory. The project directory is nothing but e-commerce market. In my home directory, e-commerce market. So what shall I do is, let me delete everything as of now. Let me go to Hue. Let me go to HDFS browser. Let me go to HD user. Select e-commerce marketing and let me delete. Okay. It doesn't allow me to delete things. Hue is trying to delete the HD user's content. So that permission is not set, hence it does not allow me to delete. So what I will do is, we know the Hadoop command. We can delete it from there. I am just clearing things now so that we can start from the scratch. We know that we can give Hadoop fs minus rm minus r minus skip trash and the e-commerce marketing. Nothing is there. We just have a empty folder hd user. Now we need to start everything. The very first thing, we will run this script. So we'll once again see how this script looks like. So these things we have seen. Now HDFS code directory will be inside our e-commerce marketing directory. We'll be putting all the code here, like the Oozie XML files, the Spark jar files, all those will come here. So as we can see here, as we can see, we are anyway removing the whole thing. Then we are creating our code directory, and we are putting the contents of our HDFS to that directory. And also we need to copy the hive site.xml to to Spark conf directory, so that Spark should be able to access your Hive. Spark should be able to access your Hive. So that's the reason we are keeping this link. So as of now, nothing exists in my HDFS. What I mean to say is, let me refresh. I mean, ignore these things, dot trash, dot spark staging, dot Oozie. Ignore this. This is nothing as specific. I mean, they indirectly are the project related things, but we don't have to do anything with that. First, we'll copy everything to our HDFS. You have to just run the script set HDFS. So this script has run. Now we can go and check in our HDFS. Let's refresh this. E-commerce marketing folder has been created. Inside that, code folder has been created. So we have put whatever was there in our HDFS folder. I mean, in our HDFS folders, build files, whatever was there in the HDFS folder, all these things we have put it into actual HDFS. Spark jar is there, or Oozie, all the XML files is there. Not all the XML files will be using, will be only using the few XML files. And these are our Hive site XML file we require. This is the initial setup query. This we should be running. So all the things have been copied here, whichever is our requirement. Once that is done, once we set up HDFS, the very first thing we have to do is the set up tables now. Using all these files, jars, or things, we will be setting up HDFS. Now, as I said that Oozie's properties files, I said that the properties files of Oozie will be in your local file system. So whatever will remain in the local file system, I'm keeping it in the local folder. So let's go to that local folder. So as you can see, our properties files are here. Setup hive oozie.properties. Now we have to just run the Oozie command. All my Oozie command, I have made it as a shell script. The very first shell script that you have to run is setup Hive. I will just show how it looks like. So this is how you run. You run it on the command prompt. Oozie job config where your properties file exists. Give the path of your properties file. As you can see, we are using setup hive oozie.properties. And this is where your Oozie server is running. Again, our Oozie server is also running on our name node service. On the system where the name node service is running. So on this IP address, our name node service is running, Hive server is running, Q server is running, Oozie server is running. All the servers are running on this IP address itself. So as I said, this is how you submit a job. So if you remember here also I said this is how you submit a job. From the client, here we are using a console client. From there we will submit a job. We need to specify where the Oozie server is running. So we have specified that. And it will take care of scheduling the job on the Hadoop cluster. So we need to specify where our Oozie server is running. So Oozie server is running on 11,000 port. Now it uses the properties file, and I said that the properties file we define input parameters and some configuration parameters to our actual job. Since our job is to set up Hive table, Hive databases and table, all the details about the Hive databases and the table is inside this properties file. So let's see how this properties file looks like. As I said, it requires the name node service. So name node service is running here. It also requires Yarn resource manager. So this is our Yarn resource manager where this process or the daemon is running. So earlier it was job tracker. They haven't changed it. Still they are using a job tracker. But actually it is a resource manager, daemon, IP address and the port. And also I'm specifying where my home directory exists, where my project directory exists. And I'm specifying my clicks data, omnichar raw path. So as I said here in the diagram, so this we know that is HDFS. Whatever table we create, it will be a path inside the HDFS. So we need to specify the omnichar path, sales path, all these stuff. So that's what we are specifying. Omnichar path is nothing but inside the project path, we have data folder, raw folder, because we will be dumping into the raw DB. So we are creating a separate path for raw. There we have omnichar, and similarly we have sales. So these are all the Oozie libraries related stuff. So these two things has to be there. Otherwise Oozie will not work. Because now we are running Hive job through Oozie. We are running Hive job, setting up Hive database. So Oozie may require some Hive libraries. So all those things are there in this part. So we need to just specify that. And we are also specifying where our Hive site XML file exists. And here we will specify where our XML file exists. In the properties file, we'll say where the XML file exists in our project, in our HDFS, because we know that the job definition file should be in the HDFS, so we are giving the HDFS file. So our HDFS is nothing but our job definition file is setup hive.xml. Properties file we saw now. Our next will be uh, job definition XML file. Let's go and check as it is in HDFS, which is nothing but in Oozie we have setup hive.xml. This is your job definition Oozie file. Everything will be in the XML. So you need to give the starting point from where it has to start. Start to setup tables. So actions are the one which define what all work has to be done. So if you want to run a job, that has to be inside action XML element. So that action name is setup tables. So you start from the setup tables because we have said start to setup tables. So we are using job tracker, which is our Yarn resource manager, and this we get it from our properties file because that's what we have defined in the properties file. And this is what I said in the, so whatever we define inside the properties file will be going as input to your XML file. So the job tracker, name node service, everything will be going as an input here because the job needs to know where the resource manager is running, where the name node service is running. Since it's a Hive job, so we also need to know where the Hive server should be running. So for that we need to specify JDBC URL. So again, Hive server is, this is how you specify. If you remember, every time I used to give localhost 10,000. Now Hive server has a separate IP address, so we have to specify that. So what we are saying is run this job by, and in this job you have to run this script setup.html. So since it's a Hive, so we are specifying our Hive script here. So it should be given in the script XML element. And this script takes some input path. That input path is nothing but our omnichar raw path. So this is a variable omnichar raw path. This will get it from the properties file. In the properties file, we have defined where the omnichar data will be there. So that we are assigning to one more variable. This variable will go as input to the setup.html. Whatever params XML element you define, these param XML element will be the input to this script. It will be the input to our script. And this script again exists in our HDFS directory. So if you go to code hive setup.html. If I go to code, hive setup.html. It's a simple Hive script, where we are dropping everything that exists. We are creating a database. We have seen all this code. Create a raw database, process database, warehouse database. The same thing we are doing it here. Partition by this, create view. So all these things we are doing. So this Oozie script will run the Oozie in the Oozie XML job definition. We have said that we have to run this script. We have to run this script, and we are also giving where your resource manager exists, where our name node services exist, and when we create the table, what is the path in the HDFS, everything we are giving as the input. So we have to just run this script, that's all. So I hope you got to understand how a simple workflow looks like. You specify input parameters or configuration parameters, and you define your job. And this job requires all your input parameters. Those input parameters will be coming as, you can access those input variables in your XML file using dollar symbol, dollar and open flower bracket and these two. So using this symbol, you can access the variables defined here. So we can check that. I'll show that once again. If I go to Oozie XML, set up Hive. So if you see, using dollar and open flower bracket and close, this is how we can access the variables defined or the configurations parameters that are defined in the properties file. So in the properties file, we have defined this. So that's how you access. Now let's run this. Submit the Oozie job. When we submit the Oozie job, it will use this properties file and it will run the job. I have to just run it. Connection refused. Some things may not be running. Just a second. Sometimes I'll just restart this service. Slightly it will take a bit time, but that's fine. Zookeeper is up and running. HDFS is up and running. Yarn is up and running. History server failed. I think it requires the history server. Yeah, that should not be a problem because it's just a history server. Says history heap dump on out of memory. Hive server is running. It also start. Oozie Hue server. I think Hue requires Oozie. You need not restart in this fashion because I think there was some problem. That's the reason I'm restarting. Otherwise, it will be up and running. So Oozie is also up and running. Somewhere configuration changes I have to change for for history server. Some extra memory it requires. I need to figure out where I can configure this. This is not related to files. It says Java heap memory dump heap to this directory using script. Let me Cloudera Spark history server. Let's check whether such configuration exists or not. You can go to the configuration here itself. You can search for, doesn't have whole interval. We have Java heap size of history in bytes. Let's increase it to 2 GB. I think this is the error we were getting, right? Java heap size. Let's make it to 2 GB. I think 1 GB also should be fine. Let's save this. So I have saved this configuration changes. Now we can, let's restart this. Now as you can see here, the history server is also up and running. So this was the error we were getting. I think 512 MB was of a bit lesser memory for the daemon to run. So now we have everything up and running. Let's run the script. So it outputs the workflow ID, the Oozie job ID. It gives you the Oozie job ID. That you can check in the Hue. Go to Hue under the workflow dashboard. Go to workflows. So as of now, you can see here it is running setup databases, and it got succeeded. So it ran that script which created those databases. So if you want to see, it will also have the logs, all those stuffs. If anything fails, you can check it here. So it has your syslogs, standard error logs, all those logs, you will get it here. So you can see here, view has been created, table has been created. So that script has been run. So everything has been run, and you can also go and check the tables in the Hive itself. Everything is provided in the Hue. Go to Hive, and if you see here in the databases, by default there exists a default database. We created processed DB, raw database, and warehouse database. So this initial setup is done. The next one is just run one more script. That's all. I mean, sorry, we have to ingest the data. Ingesting of data, I have not automated that because it will be through some cron tab, because it will not be part of HDFS. From outside you will be putting the data to HDFS, so it will be part of some other cron tab. Somewhere else the server, you have to run your cron tab scheduling. It will not be part of, hence I have not included that. So you have to run this script. It is just a simple script which will copy the data to HDFS. That's all. So as usual, since we need to copy the data to HDFS, we need to specify the name node service. And my home directory is this. My project directory is this. and this underscore success and all is required for Oozie jobs. And we are creating our Hadoop Omnichar data directory. So these things, if you remember, we had seen it earlier. For 7 o'clock, a 7 o'clock folder will be created. For 8 o'clock, as soon as you run this script, if you are running it at 8 o'clock, a 8 o'clock folder will be created. If you are running it at 7 o'clock, 7 o'clock folder will be created. So this we know. Only changes we have done is we have included this name node service. So let's run this script. It will ingest the data. So as of now, if you see, if you go to HD user, we have e-commerce marketing, we have data folder, raw folder, Omnichar, but inside Omnichar nothing exists. Inside Omnichar nothing exists. When we run this code, when we run this script, this will copy the data. And we know that our data exists here itself. Here itself I have the data. So this data I have to copy it into HDFS. So if I go to demo data, so I have both Omnichar raw and I have the sales data. This we have discussed while explaining the project. So I have to just copy these data to HDFS. So to do that, I have to run the script. So only 3 scripts these are all for testing purpose was done. These scripts are not required. Only the first 3 scripts are good enough. This is for initial setup. Once you set up your database, ingest the data. Once you ingest the data, you run this coordinator job, which will run every hour of the day. This will take care of running every hour of the day. So as of now, nothing is there. So the ingest. So this is how I ingest. It takes you need to give where your local Omnichar data exists and where your local CSV data, sales data exists, and run the script. It will just copy the data to your HDFS, nothing it will do. So as of now, you can see it has copied. So it is showing R is 03 because my EC2 instance is in UTC timestamp, because internally it uses the UTC timestamp, hence the R is 03 and not, since it is 835 here, it is not showing 835 because it is under UTC timestamp, hence the R is. So you can check that as well by giving the date command on your Linux terminal. When you give the date command on your Linux terminal, it will show what is the current time there. So it is 3 o'clock 36 UTC timestamp. Hence a folder by _03 has been created. So we have our Omnichar data. Similarly, we have our sales data. Both the data has been copied. Tables has been created and the data is also copied now. Now all the 4 jobs has to run. Partition job, Hive partition job, Spark job 1, Spark job 2 and Spark job 3. So all those 4 jobs, we have to run it every hour of the day, hence we need to use coordination workflow. What we'll do is, I think it will be too much. So the coordination workflow we will see tomorrow. Because it requires a bit of explanation on how the coordination workflow looks like. It will finish in 20 to 30 minutes, but let's take it in the next session. That is tomorrow. Tomorrow same time, 7 to 8 o'clock it will be finished. As of now, what we have done is we have just created these tables and we have ingested the data using that shell script. That's all. Now we need to understand the Oozie coordination job and should start one after the other. So thanks everybody, and have a nice day and good night.